Hello everyone, and welcome to part 3 on logistic simulation with AnyLogic, building a smart robot with multi-load capabilities. In this video, we're continuing our exploration of a robot-based logistics system. If you haven't seen part 1 or part 2 yet, I highly recommend checking them out to get the full context. Let's start with the problem we're tackling. In our model, boxes appear dynamically in a zone we've named Boxes Appear. These boxes are generated directly from an Excel file, and each one has a defined source and destination. Every few minutes, a new set of boxes is injected into the system. Each box is associated with a specific color, which determines its destination. Yellow corresponds to destination 1, blue corresponds to destination 2, and red corresponds to destination 3. The robot's task is to pick up several boxes at once and deliver them to the correct destinations based on this color coding. It's a challenge that mirrors real-life delivery optimization problems. Now, let's talk about the robot behavior. We built the robot agent completely from scratch using AnyLogic's agent-based modeling approach. Using state charts, we modeled its internal logic and tracked its transitions by collecting statistics each time it enters or exits a state. This robot has a multi-load capacity, meaning it can transport several boxes with different destinations in a single trip. The TOs support this behavior. We implemented a custom block based on the move by transporter logic, which allowed the robot to carry and drop off boxes according to their destination in an efficient way. So, why did we build this model? The aim was to explore the impact of different strategies, using multiple robots that carry only one load each, versus using a single robot capable of carrying multiple loads. With this simulation, we're able to simulate dynamic arrivals and deliveries using real-time data from Excel, implement and test advanced delivery behaviors, compare different strategies and their performance under various conditions. Now, let's go through the key steps of how we set up the logic behind box arrivals in our simulation. Step 1. First, we create a database that contains the core information for each box, an ID, a source, and a destination. Then, in the box class, we added these same attributes so that each box object can hold that data. Step 2. Next, right at the beginning of the simulation, we load the data from the database. For each row, we create a new box object and assign the appropriate values to its attributes. All these box objects are then added to a list in the model called C_CDB_box_arrival, which we use to manage the incoming flow. Step 3. Finally, we set up an event to simulate the arrival of boxes. This event is programmed to inject 4 boxes every 30 seconds. Once all the boxes in the list have been injected, the simulation automatically stops. I'd like to walk you through the main steps to design a multi-load robot in AnyLogic. Step 1. Defining the robot flow. First, we need to model all possible states of the robot. The journey begins at the start, followed by a movement to the home position, move to home. Once idle, the robot transitions to move to box, then loading, followed by move to destination, and finally unloading that the robot still carries more boxes. It repeats the cycle from move to destination. If not, it checks if there are more boxes waiting to be picked up, and if so, it goes back to move to box. Otherwise, it returns to home. Step 2. Managing the box flow. At the same time, we must manage the flow of boxes. When a robot reaches a capacity or starts moving, boxes must be blocked from entering the delay_load block. Once the robot arrives at the destination, each box passes through a delay block to simulate the unloading time. Step 3. Robot icon and visualization. The robot's icon is also important. It allows us to visualize the process in real time, showing the robot's current state and displaying useful data, such as its load or the number of trips made. It also reflects any parameters entered by the user. Step 4. Parameters and actions. This step is about defining key parameters and actions. These actions are triggered when a box enters or exits a specific block, or when the robot completes the loading process. This is useful for adjusting behaviors dynamically during the simulation. Step 5. Data collection for statistics. Now comes the analytics part. We can track several variables: the time spent in each state, the number of boxes waiting, how many have arrived, been delivered, or unloaded. This is essential for measuring performance and understanding system efficiency. Step 6. User interface design. Finally, we build a user-friendly interface that allows users to input data, launch actions, and interact with the simulation in real time. This adds flexibility and enhances the simulation experience. All right, let's start the simulation of this mini-model. We'll observe how the robot respects the delivery limit at each destination. In this example, the maximum is set to 3 boxes per destination. As you can see, even though 4 boxes have arrived, the robot only picks up 3. That's because its capacity is limited to 3 boxes. Once it reaches a destination, the boxes are delivered correctly, and the robot comes back to pick up the 4th yellow box. Then, another set of 4 boxes arrives. The robot does the same thing. It picks up 3 and leaves 1 behind for the next trip. We can also notice that it should have started with the yellow box. But due to the FIFO rule applied here, it follows the order of arrival. This rule can be changed or extended depending on your needs. Feel free to leave a comment if you'd like to explore different logic or delivery strategies. You can also follow the 3D animation, and we've added detailed KPIs for each robot, which you can monitor during the simulation. Finally, we can examine the code. If you'd like to run the model on your side, feel free to comment or ask your questions. We're happy to help. And now, we're reaching the end of the simulation. In this video, we covered creating agents from a database to simulate box arrivals in the source block using Excel, parameterizing the move by transporter logic to support multi-load handling for robots, adding KPIs for each robot state. In Part 1 and Part 2, we explored multi-robot and single-load scenarios. I end this video. Part 3, we focus on customizing a single robot with multi-load capabilities. Thank you for watching. Feel free to leave a comment if you have any ideas or suggestions. And don't forget to like the video. See you soon.